to look instead at a sort of famous map. I was sort of an early proponent of data science. This was from a cholera epidemic in 1854, put together by a physician named John Snow. So somewhat timely, although I didn't want to do anything too current. On this map, he was mapping cholera outbreaks in London. And people weren't exactly sure how cholera spread at the time. John Snow had used this data to put forth a theory that it was bad water that would do it. In fact, what he did is just someone had cholera, they lived at a particular address, he would increment a little bar on this map. So by today's standards, this is probably not how you would plot the data. But at the time, this is actually really, really inventive. And you can see like, oh, there's a big one here, small ones here, smaller ones here, other ones around here, all centered around this region, Broad Street. There's a water pump right here. That was disgusting. That was the center of this particular epidemic. So what I'd like to do is, in a sense, try to recreate this plot if I can get my hands on his original data, which I'm not 100% sure what format it's going to be in. I've done a little bit of digging here. There's a thing called, Google Fusion tables, but that doesn't exist anymore. So we are going to have to do some digging. Let's make it dirt. Let's call it Snow for John Snow, the guy who made it. Not the Game of Thrones guy. Different John. Physician in England in the 1850s. Let me see if I have that in my downloads. I tried to download this. What is it? John Snow. Okay. John. Alright, maybe I didn't download it. Let me try to get it then. Oh, this just goes to someone else's blog. Oh, come on. Just give me the data. This is whatever.zip. Okay. This is going to be a bit tough because it's all done in like ArcGIS formats. So we're going to have to do a little bit of futzing to make it work with us in Python. I can just get some nice XYs or something. That'll make my life a little bit easier. Let's open that up right here. Let me just unzip that right away. So we got the various shape files and other things. This is probably the street map. These are where the pumps are. That tells you what's bad about the pumps. Let's take a look at the README. Always a good idea. GSers leading in John Snow's 1850 gas station cholera outbreak. Hey, read all about it here. This is a modern map of the area of the outbreak. That's grayscale. Oh, it's Snow's original map. Oh, that's cool. Geofenced and warped so it accurately overlays the US map. That's cool. These are where the deaths occur. Attribute value gives number of deaths at that location. Okay, so rather than getting a whole bunch of death, you just got to count each location. That's convenient. And the pumps, where are the actual pumps? So what we're going to end up having to do, really, is handle all this GIS type data, which there's things to do in Python. And I've dabbled in, but I haven't explicitly done a lot of work. A ton of work in that area, I should say. Actually, can we display snowgis/snowmap.tiff? Yeah. So here's a big view. Oh boy. Big view of the original map. You can see like he's literally marking every death. It's just like an extra slash on his line. And there's a pump. Boom. There's another pump. A couple other pumps around here. Like he didn't do a statistical analysis, but here it's pretty clear. This one especially, there's probably just a lot of people living here. You really want to index this by, well, what's the population density? Perhaps around here it was all about the same. But this can give you some clues as to this pump, totally fine. This pump, really bad. And this might seem obvious in hindsight, but I assure you it will not be obvious if you're just living around there. Yeah, maybe oh yeah, people in this neighborhood are having a hard time, but until you see the data in the right format, nothing is obvious. John Snow found the right format. It probably took him weeks. I was looking at his Wikipedia page, but didn't see explicitly how long. We're going to see if we can do that a little faster. One, because we know the right answer. Two, because we have modern tools and methods to assist us with doing that. So, first, we got to read in this various data. I don't want to be in this directory anymore. Snow. I want to be in this directory. And, okay. Proj/snow. Cool. Open up our IPython. That's what we're going to do. Our Snow GIS. So we need to read in our deaths. We need to read in the pumps. And like we could read in the map too, I guess. That kind of thing. Might be handy to do. This might take us more than 1 week, and you know what? That's okay. This isn't a machine learning project. This is just like a data visualization project, which is also an important part of the channel. Because again, looking at data the right way is what helps you understand what's going wrong. So we're going to say Python, read GIS. I don't know, shapefile is what I want to read. I don't know. How to read a shapefile. People were asking about this on here. Fiona. What? Oh, GeoJSON. I've futzed around with it before. I've never heard of Fiona or PyShape. Oh, OGR I've heard of. OGR. Conversion to shapely geometry. Hey, that'd be fun. I don't know if that's really what I want. I just want to get some XYs, plot some things. That's really what I want to do. XYs like lat longs or whatever, who knows. Shapefile. Shapefile, do I have any of these things? Let's see what if I haven't have anything. Import Fiona. That's such a weird name for... Okay, what about shapefile? Let's see. OSGeo, is it called? Or OGR? From OSGeo, import OGR. Alright, so I don't have any of these. Here's a question. Apropos shape. Nope. Shell parameter is funny. Just trying to find, do we have something along those lines? We do not. I don't know. That looks pretty good. This looks pretty similar. I feel like shapefile might be the most convenient, although I know OGR does some pretty fancy things. Let's try shapefile. So let's just go pip install shapefile. And I might have to sudo do this, because I'm a terrible person. And I just have one giant Python environment to do everything for me. That's taking a while. Come on. So we're going to want to import. If not, we'll just have to reverse engineer the format. Actually, can I do... Yeah. Cholera dot shape. What does that look like? Well, that's some horrible binary mess. Like, there's clearly a bunch of records here. But you don't want to have to read that. That's no fun. So what is this other stuff? What is DBF? I don't know what that is. Yeah, I'm not super familiar with these other formats. Proj, this is telling you, like, what grid is it on? Some super old grid. And what else we got? SBN? What is this? I have no idea what that is. No clue. Can I just like convert shape? I don't know, XY or something. Shape to lat long converter online. That might be kind of what I want. Drag or browse files to convert. Your data will not be shared with anybody. Yada 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 yada. That's basically what I want. Yeah, no, we're just gonna give you a file, pal. Snowgis. Yeah, let's just try this. DXF and SHX. Okay. Can I just do like this? Go nuts. That's fun. This shouldn't really take that long. I just saying, I'm so unfamiliar with this type of data. I don't know what all these different pieces are. That seems to be choking. You should consider upgrading, blah, 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 blah. You're using an old version of pip, can have our version is satisfied, yada, 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 yada. Okay, fine with that. So not shapefile. What about Fiona? Again, this should not take forever. I don't know why that took forever. It's super weird. This seems to be choking. Try this again. Add files. All these. They're not particularly large. Hey, what do you know? Continue. I gotta have to make an account to get this data then. Input layers to convert. Sure. Output comma separated value. Yeah, sounds good. Coordinate system, same as input, merge output files? I don't know. Yes, hey, what do you know? It's in England. There's Broad Street right there. Not that broad. Maybe it was broader at the time. Does not contain... I don't want to really care about projecting it onto the earth. That's not a big deal. Convert now! Download it! That's super convenient. MyGeodata.zip. Okay, great. Let us... Screw this nonsense. We're not going to be doing any of that. Move, downloads, MyGeodata. That's going to become cholera.zip. Unzip cholera.zip. Cholera.csv. Boom. Nice. Okay, let's extract and convert OSM data. No. I want to go back. Get more. Yes, the convenient little website here. Pumps. We need pumps. Oh, I missed the proj file. Oh well. Hopefully that's not important. Maybe that contained the... Oh, that's the projection file. That's what it was. Let's go download that right now. Cool. Let's move that to pumps. You know, this may not be the most exciting thing, but like this is how you have to get your data. And I need to remove this one because I didn't have the right thing. And I remove cholera because you got to have that projection if I want all these things in the same setup later. I wonder why is that 2 years older? I wonder. Mysteries upon mysteries. Okay, now it has a projection. Now it should be totally fine. Convert now. Output coordinate system is some hot mess. Okay, 1, 2, 3, 4. That's no. Don't want that. Don't want that. That one. That's what I want. No such data or directory. Oh snap! I gotta download again. Download. Abort that up. All right, we'll see how much progress we actually make then. Okay, so we're not gonna be doing nonsense with shapefile. We're gonna do straight NumPy and Matplotlib, I think. There are better plotting libraries out there, particularly if you have lat long data. But we'll see what we can do on Matplotlib. Might not be super great. But anyway, we'll do what we can. And would also like his original map. It's like a TIFF. Oh, is that a thing I can just grab like this? Yeah, let's find out. Oh shoot, I grabbed all the pump things, yeah. Let's see, does this work? Take a little longer, it's a little bit bigger. I'm also uploading all this video, so. I found it a little strange how they've chosen to implement this progress bar, that your percentage is always halfway to the end. Almost there. Almost there. Okay, fantastic. Great. Continue. Output formats. Can I... Golden Software ASCII Grid. That's cute. PDF. No. KMZ, image raster, PNG. TIFF is probably fine. SnowMap, TIFF, SnowMap, whatever. This is his original map, right? Yeah, let's do that. Let's convert it to a TIFF, I guess. Even though it's already a TIFF. Not change either input output recorded systems, nothing to convert. Oh, okay. Sure, give me PNG. That sounds fun. No. You see number of datasets, which is 3 datasets per month. Alright then, we won't be converting that. My apologies. That's not going to happen. But we got the important ones. And we'll plot these wherever we plot these. Okay. Those are all there now. Let's take a look at that data. Pumps. This is some sort of X location, some sort of Y location, and some ID. Because it's a pump, they're all the same, maybe? And tab new Cholera. Again, some sort of X, some sort of Y. I believe these are on the same grid. Yeah, sure, that's fantastic. We'll just like subtract a mean. And here we have a count in all these situations. Okay, cool. Now we can do some damage. Let's get pandas as well. So, let's start with reading this stuff in. Yes, go over there. Let's read in the pumps first. It's a simpler type of data. read CSV, and this is pumps.csv. And let's, what? I don't need that. Oh, what did I do? There we go. Hang on. Kill that. There we go. Much better. Take a look at the pumps. You got an X, you got a Y. I don't know why there's unnamed things. There's nothing unnamed there, is there? No. Nothing unnamed. It's... Pandas is being a little bit silly. That's okay. So what I really want is... Can I ask for pumps of X and Y? Is that a thing you can do? Nope. But I bet if I put it in a list... Yeah, there we go. Okay, cool. And if I turn that into an array... Tell me something good. Okay, excellent. I'm going to say pump array, PA, is equal to pumps of X, Y, and we'll convert that just straight away into an array. Awesome. Okay, and what I want to do is I want to recenter everything and say that C center, so numpy.mean PA axis equals 1, I think? No, 0. Well, it helps if I define that. It should be too long. Yep, perfect. So those are the centers of all the pumps, but I'm going to use this as my global center, just to reorient everything. So we're not dealing with these 500,000 whatever number nonsense. So PA prime is equal to PA minus center. And now, these are considerably more reasonable values, you know, in some not crazy range. Cool. So that's read in pump data. Now, of course, Jon Snow has saved us a lot of trouble. He's already done all the counts at these particular positions. I assume these are like actually addresses, and they've been converted to geo-coordinates. So someone has saved us a whole lot of effort. Read in cholera deaths. So going through and collecting that data would also be a huge part of the work that you have to do. Let's say cholera. No, this is deaths. But it's cholera deaths, capital D, that's CSV. And this is our death array. Not pumps, but deaths. I need XY locations and I need counts. Let's see, what does that actually look like? Deaths. Deaths.columns. Count, singular. Okay, we can work with that. Count. Cool. So, these are all the values there. We're not going to mess with the... obviously, we're not going to screw around with the counts. And those should really be a separate array. So what I want is... death array positions is just death array of all the rows, just the first two columns, minus the center, right? And death array of the counts is just DA of all the rows and the last column there. So simplified things a little bit. And if we need to put them back together, we'll put them back together. Cool. So these are a bunch of positions, a bunch of XY positions, right? Those are on the order of 100, those are on the order of 70-something. It's all good. Some are positive, some are negative, some are very negative. Interesting. These numbers, you know, the pump numbers, not necessarily lined up with all this. That's okay. That is okay. So, something you can do. Can I read in the map maybe still? Hang on. I still would love to just read in that like TIFF, just so I have it. And like try to futz around with my center to get things to line up nice on it. Actually, now that I think about it. See, proj snow. What we're gonna do? Can I convert snowgis snowmap.tiff to snowmap.png? Is that a thing I can do? Come on, come on. Unknown field, warning, 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 warning. Did not do it. Oh no, it did. Snowmap.png. Cool. Now it's a quick PNG. Yeah. It's still, you got the. Yeah. What's 0, 0 in this universe? I have no idea. I have no clue here. Scale 30 inches to a mile. Well then. Yes. There's probably some way to read in a geotiff. We don't have that information right here. We're going to try to do some hacky things. Within a localized environment, it's not going to be a big deal. That is not a proper projection. That's okay. But we'll get to that in a second. What I would like to do... Gosh, why did I just import matplotlib? That's never what I do. I want to import matplotlib.pyplot as plt. And we'll do plt.ion. As always, over here. Okay. That is going well. So what you want to do is do like a plot.scatter of like DA pos. I think that's the kind of thing that we want. Kill that. That gives you, that asks for a bunch of x's and a bunch of y's. X comma y, array-like shape, scalar, the marker size, in points. Okay. So what we'll do is say all the rows, first column, all the rows, second column. In fact, I'll make this a little bit more explicit. X equals. I'll try to be a little good here. Y equals. And then the scale, how big the points are going to be, should be this one. Ah, okay. So now our size of points is colored by our things, and this kind of follows the road, so it all makes sense. I should show my pumps as well here. So similarly, we will plot.scatter, and I want to turn off auto indent because I already do that to my text editor of the pump information. So x equals this aspect of the pumps, which is all the rows, comma 0. And yes, if I had kept this in a pandas array, maybe this part would be a little more convenient, but I like having less distance between me and the data. Okay, so these are the location of the 8 pumps of interest. And this is the location of the actual, of all his data points here, which are clearly little points. So really we should plot the pumps first, I think. Show pumps. Show death count. All right, now this is not exactly the same, clearly. This is the same type of map. In fact, if you look around at what other people have done, they created something, hey, very similar right here on an actual map that we've read in. Now, if I want to plot there's plot.image show. Display an image, ID data, and 2D regular raster. Can I just pass in like a file name? Image data, supported array shapes are. Is there a plot like imread? That's a thing, right? Yeah, okay. Can I read a TIFF? That is an interesting question. Snowgis slash snowmap.tiff. Is that a thing you can do? That's monstrous. Absolutely monstrous. A.data is just a point in memory. Okay. What if I plot that image show AA? What happens then? Which data cannot be converted to float? Bummer. Alright, so maybe that's not going to work out so well. Let's do imread on snowmap.png. Okay, now we got our data. We have data, right? Yes, okay, good. Just making sure it's all black and white. Well, that makes sense. It's all black or white, in fact. You have two choices, or one choice. Oh no, what have I done? Yeah. Okay, so I need the center of this map to line up with the centroid of my pumps, which is going to be hard. It's going to be real hard to do. So what I'm actually going to do is change how I compute the center, and I'll just pick one of the pumps, and I'll find the same spot of that pump in here. So, one of the pumps, whatever one this is. Shoot, I did not label these. Fudge. Okay, but pumps, approximately there. Where's the center? Oh, that's not what I wanted. Here we go. We can do this bit we can do manually. So which pump is closest to 0, 0? That's the one I'm interested in. I think this is the magic pump. This is the Broad Street pump, and this is Broad Street. I believe that's the case. So you're looking at about 17 and negative 100, or 18 and negative 98. That's close enough. 0, 1, 2, 3, 4, 5. Okay. So center is now just going to be PA of 5. So let's do this. So now it looks slightly different. See, that's 0, 0 now. Cool, cool. I will just need to change, or, yeah, hang on. I compute this center. I find the center, let's read in the map data, actually. Read in Snow's map. There we go. Map equal, no, I don't want to call it map. M, let's plot that imread of snowmap.png, sure. So m.shape. This is centered like that, which is not at all how my things are centered. So where is that equivalent map, or equivalent pump on this little map here? That should inform what we want to do here. So it should be right here. So where are we at? If you look down in the lower right here, down here. You know, I would say 1678 and 1306. So let me take a note of that. 1678, 1306. Oddly enough, when I say numbers, it's so much easier for me to remember them. But if I don't do that, it's hopeless. Absolutely hopeless. I just stare at it and try to remember it. Not gonna work. Not gonna work. Okay, so this is killer pump, whatever. So this position, I want this position to be, hang on. Gotta think about this now. Like in my ideal universe, I just plot this map. Where's my map? I plot the map like this, or however I want to plot it. Who cares? And then, in fact, this is right side up. Yeah, there's Broad Street. We plot this map, and then plot the other things on top of it. So I have taken all of this stuff relative to this point, right? But what I need to do is make them all relative to this 0, 0 up here. So we're doing a little bit of futzing around that if we could read in the actual TIFF, we wouldn't have to think about it all. So I'll say KP, the killer pump, is at an array position of 1678, 1306. I'm just doing everything as XY. Not even... Don't want to try to think about rows, columns. You're going to go crazy if you do that. That is where the killer pump is. So everything is going to be relative to whatever this pump is. That's fine. I center everything. That's the same pump. I'm pretty... Actually, I should verify that. Verify that is the same pump. Zoom in a little bit here. Yeah, he makes his pumps harder to find, but he doesn't have as many colors, so I don't blame the guy. Well, it should be the one that's next to the super high counts. So, let's check that. I thought there was one right here. Is it down here? Like, this is clearly the super high counts. Are these not on the exact same array? There should be one right next to the super high count. This is the super high count. Oh, no. These are a little bit mucked up then. Did I not redo this? Maybe I didn't remake my DES array relative to the new correct center. Yes, that was the... Oh, jeez, oh man. Kill all that. Oh boy, I didn't remake the DES array. DES, yes. Okay, this one, not this one. Oh, okay, wrong pump in my centering. This pump, which is at like negative 6200. PA, which one is that? Hang on. PAP. Yeah, well right now it's at negative 6200. This one. Oh, the first one. How convenient. Okay. Recompute my DES. Come down here. Now this pump is at 0, 0. Cool. So what we need to do is move this pump and everything else along with it to this location. So, come back here, kill that. We subtract the center, but we add KP. So that should put everything in the position of interest, plus KP. And then, hopefully, I can plot all this stuff together. That's my position of the killer pump. Whatever, we'll read all this stuff in again. Okay, cool. So this is at position, 1678, 1306, whatever. We need to plot this map, though. Show snows map. So I think we'll have something, and we probably won't end up doing multiple weeks in this, but show snows map. We might futz around with a couple different things we can do to make this a little bit easier to see. Plot that im show. Can I declare what type of CMap? Yes. Plot that im show of m. CMap equals gray. For that classic quality feel there. Okay, let's see how well it's worked. Okay, well, I got everything on this map. I might have things, there might be some XYs that are inverted here. Yeah, like this is like trying to go like this. It should be going like that. 0, 0 is still 0, 0, right? But the way things are being displayed has gotten all mucked up, which is only a little surprising. So what I think needs to happen is the X's are all totally fine, I believe. As you go over this way, it's correct. The Y's need to be reversed. I think that's what needs to happen here. And they need to be reversed in the context of this, about this point, right? So I have a whole bunch of Y's, right? DA, pause, all this nonsense. A whole bunch of Y values. Most of them are positive, but not all of them. Those are all positive, actually. Harumph. About that point, so before you add the killer. Okay, hang on, we can get there. We almost got this. Oh, and I didn't, hang on. I don't subtract this from center? No, of course not. Of course not, that'd be silly. DA pause of all of them, the Y's, times equals -1. And then I say dA pos plus equals. So we'll do that. And we'll do that over here as well. So PAP, all the rows, and the Ys, flip those, and then PAP plus equals our killer pump. Because we were centered around that point, so we want to fix that up. Alright, let's see. Does this look vaguely correct? Not necessarily. Well, yeah, okay. Yes, I'm willing to buy into some of this. I ran the desk, ran all those things. Let's make a new map. Okay, I think this is starting to look reasonable. Doink. Yeah, there's some slight, ever so slight offset. We might want to futz around with that. But we've got our, I think the scale is different here too. Oh shoot, I didn't think about that. I did not think, I needed a second reference point to know how to scale things. Oh yeah, having that proper TIFF would have been nice there. So here's another pump down the road, which is probably this pump right here. So we need to do like a full affine transform of like, take this point, take that point. All right, so we got to scale everything this much. Like this is 0, 0, that's there. Well, actually it's down here. Whatever that, pump number 2, 1856, 1855, 1856, 1939. Okay, let me just save that here. 1856, 1939 is P2. That's killer pump, not killer pump. P2, I don't want water. And at this point, you might just say, you know what, why don't we just use that original map? Well, sure, that's probably a good idea. Or, yeah. Well, let me ask this question. Is there an easy way to read GeoTIFF? Python read GeoTIFF. About the GeoTIFF raster format. Earth data science. Reading raster files. GDAL, we don't have any of this nonsense. Like raster Earth Pi? I'm not going to have all that nonsense. No data with height. Oh, it usually tells you the affine transform. Yeah, that's really what we're going to end up doing here. And of course, you might have to take this map and twist it around and do terrible things to it. I don't think we'll actually have to do that. Let's see here. I don't believe we're going to have to twist too much. Like, our data might be aligned to this grid here. Does the slope of things look okay? Slope is close. Not great, but close. Yeah, again, because we're trying to plot onto this stupid thing. His stupid map. It's not stupid map, his map. Which is totally fine. But we're in, you know, insano coordinates. We have to convert our original coordinates centered around this pump with this other pump as a reference point. As a second reference point, I should say. There's got to be... Do I have affine? Affine. I don't have affine. Sudo pip install... I thought there was a way to just do this with some reference points. Can I import name main? Cute. I don't know why my pip wants to be annoying, but it does. It's just super old and super dumb and taking a long time. And why you gotta do this to me, Pip? Why? Alright, we got 20 minutes left. What can we do here? Let us try to correct the scaling then as well. So, you got all this. zooming in our points here. Another thing I could do, possibility here, would be to change like where 0, 0 is on this map. Because really it's just like the extents of this are different. I don't even see where these other pumps are. Here we go. That's one pump down lower. There's a bunch of other pumps though. Is this whole thing a pump down here? Yeah, it is a pump down there. Okay. Things that are like way out, way the heck out there. So it's like, what is this distance in my world versus what is that distance? That's screwed. Permission denied. Okay, well that's at least. Can't import me. Alright, screwed. Deal with that later. It's whatever this distance is, however we should scale it. You know, presuming the x and y have the same scale, so they don't necessarily, but they're probably pretty similar given the small range that we're looking at. So it's a matter of this distance versus this distance. So that's relatively easy to compute. Relatively easy to compute, I should say. Which pump is that? Is pump number 2, the pump of death, the pump of not death. Let us show just the pumps. This is what in the googly moogly am I looking at? I gotta have everything. I have to have everything. I can't not do that. Apparently, losing my mind. This pump, which in this universe is 1727, 1502. No, that's not what I want. PP. 1735, 1504. Yeah, I think that's the one I want. 0, 1, 2, 3, 4, 5. All right, that's number 5. My ref pump. PAP, whatever, 5. That's fine. So, what is the distance between those two things? So, my dist 2 here is going to be just square and take the square root. Because that's relative to 0, 0 in its universe. Nope, it's relative to 0, 0 before I do this. There we go. That's fine. Before you add the killer pump. Then that changes what the 0 is. That's fine. Dist 1. Dist 1 is just P2 minus KP squared. We'll take the square root of that as well. Okay, this gives us our distance 2. So scale everything by that. Dist 2 divided by dist 1. Right. Other way around. Right, if this distance is bigger, I need all these distances to be bigger. Okay. I can use this same distance down here though. Oh boy. Again, before you multiply, dA, hang on. Yeah, dA pause, there we go. Then you multiply. Let's see how this goes here. I need a P2. Dist 1. Do all that stuff. Do all that stuff. Let's see how the simple scaling handles this. Alright, that's actually looking not terrible. That actually looks pretty dang good. Huzzah! Look at that. Pump, pump, pump. It's a little bit off. I'm going to grant. It is a little bit off. That is way better than I thought. Okay, cool. One thing, these these little points to tell you how big it is, you can't get them any bigger. They're always the same size. I mean, they're bigger relative to each other, but their absolute size does not change, which is a little bit irritating in this context. Okay, cool. Now we can do something a little bit better. With our plot, I should say. We are successfully able to transform Okay, scalar, C, color sequence. It's really good. No, S is like scalar size. Marker size. Default is this. Da, 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 da. C should not be a single numeric RGB or sequence. Yada, yada, yada. Marker. Marker style. No, 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 no. Norm. No. Vmin, Vmax. Line width, edge colors. I don't want any of that nonsense. What I want is like matplotlib. I don't need any of this stuff of it anymore. Alright. Matplotlib. Scatter like absolute size of dots. There we go. Marker size, yeah. But like, why does the marker size in point squared? It's the size in point squared, which is another way of saying it's an area. So it scales with area, which is So we might want to scale these up here. No, this is just explaining what it is. Plot marker size, plot line width, scatter S equals 22 squared. That's weird. 10, 10, 100. You've got some mistakes or something weird there. Area units. Doubling the marker size quadruples the S parameter. Yes. Doubles the S parameter. Yeah, I know that. Is there a way to make the type of marker or something? Marker equals S. Oh, a square. Oh. That's actually interesting. Pumps we're going to leave circles. Right. I want those to actually be rather sizable. And they are. They're a reasonable size on here. When you zoom in, they don't change, but that's fine. But these, I want to be a little bit bigger. Right? So times 100. Which is not actually going to change them that much here. Okay, no, it's going to change quite a bit. I lied. I lied. Times 10. And we might need to make them transparent. I'm pretty sure you can control the alpha channel. Can you? Alpha, yes. Alpha equals 0.5. So make some transparency, but if things overlap, they overlap. Whatever. Okay, there we go. Yeah, I kind of like want the color to be related to the count as well. C equals DA times C. Let's see if I can get away with that. I don't know if that's a thing I can actually get away with, but we're going to try. Look at that. Look at that. Now you can see infectious disease right here. That's super cool. I dig it. I dig it. And let's add a little plot dot color bar. You like a color guard? I like a color bar. Going in right here. And now you can see. I don't know why there's all these little funky gradations here. That doesn't really matter. That's irrelevant. Point being, hey, there's 14 here. The highest. Cool. Whereas these other ones, not so much. Doink. And there you go. Yeah, that actually, I still think, I kind of think Jon Snow's makes it a little more obvious here. I do like his format there. So let's see if we can try to match his a little bit more with the tools that we have available. So we're going to change the marker equals a square for these guys. Yeah, okay. And then I want to change the width of that square. Is that a thing I can control directly? Let's see. Width. Not equal to down here. Is it Vmin, Vmax, line width? Scalar line width of the marker edges. No default is. Oh. You can pass in an array of this nonsense. Ho 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 ho. Well. Line width. Right? It was width. No. Shoot. Line widths. Plural. And this is also the same thing. Just how many different ways can I show the same thing, right? Okay, that's... Well, that's like the exterior line width. That's not what I wanted. That's cool, but not what I was looking for. Alright, that's... What was I looking for? The edge colors, there was like a line width at the marker edges. No, the Stack Overflow is making it look like line width. This one. Marker size, line width. Oh, here he's defining a specific box. I see. Whereas I'm not defining a box. So maybe matplotlib. Actually, what are my options on the marker? There might be more interesting marker options. Instance in the class or text shorthand. See matplotlib.markers for more information about marker styles. Okay. Matplotlib.markers. Point, pixel, circle, triangle, square, pentagon, star. These are all things that are kind of like radially symmetric. V-line, H-line. Those are the ones we want, my friend. Let's go with a V-line. So we'll do a little pipe. Let's try that. Let's try that, see what happens. That's what's convenient for us is like we can just try different things, you know, and see what works. Gosh, those are really hard to see. Those are real hard to see there. Holy moly. And it's not like zooming in is going to help me. They're not going to get any bigger. Okay. In this case, then, I do want to make their size even larger. Okay, that's a little better. And I might want to increase the width a little bit. Yeah. Maybe this line width isn't what I want. None of that nonsense. None of that now. Uh-oh, what'd I do? What'd I do? It's not happy. There it goes. How do I control the vertical line width? Matplotlib. Marker, vertical line width. Vertical lines, max V line. That's where you put it, but not how wide it is. Hang on. Line style, line width. What does line style do? Oh, that's a different kind of thing. Line width equals, I don't know, 2, 5, 10, 10. Let's try 10. See what happens there. Logically, whoa, no, yes, okay, that's the right concept, but way too much. Let's try like 3. Okay. This is still like a little bit much, but we're getting closer. Yeah, so now like this big yellow one kind of stands out. I think there's actually too much transparency. Off 0.75, I think would be better. That's part of the problem here. We will wrap up tonight at 6. Question from the chat, where's my vimrc? Is it on GitHub? It actually is on GitHub. I keep all those things on GitHub because I am paranoid. I keep everything in a big repository called .files you can find. So you know what? I'll just paste it in chat. That's the easiest way to do this. So you'll get that in a second there. That's my vimrc, however. That is not what gives me this incredible power of just casting lines from Vim over here over to IPython. That would be Slimux, my friend. And that is such a good thing. It's so good, I'm going to take the time to find... I'll find the vimrc, and then you'll see the Slimux things that I have in there. At least I'm pretty sure. Let's see. Yeah, so That's my specific MRC. There's a couple things I'd like. But the key bits are Slimux. So Slimux is love, Slimux is life. Like Slimux, all the things. That's what this setup is all about. A lot of people use Jupyter Notebooks. Jupyter Notebooks are good, but not as good as Slimux. Nothing is as good as Slimux, I've found. Oh no! Okay. This is probably close to as good as it's getting. I don't know how to make all these things angled. Unless there's a like a marker that's angled in some funny way. Actually, there might be. Tick up, tick down. Like, what is this? Tick left, tick right, caret left. Nothing. Render string using math text. List of XY pairs used for path vertices. A tuple. Like, you'd have to get a little bit more fancy and do rotated lines, probably. Diamond, thin diamond. Because I'm not going to be able to declare the angle that this is going to be at. Point pixel. Oh, cool. That's kind of neat. Okay. 70. Sorry, I was looking at the alpha level, though. Is that any better than it was? How do you spell it? I will type it in chat. S-L-I-M-U-X. Slimux. I forked that repository as well. But I think I use mainly the current version. I might have a couple custom changes. They might have a couple changes ahead of me. Whatever works for you. I have a separate video on my YouTube channel that you can find as well, where I go into far more details about using this setup. So I highly recommend you check that out if you get the chance. Okay, we got our pumps. We got our business. This is like still just like a little bit too busy. Maybe it's just the line width is a little too big. I just want it like 2. Maybe the color is like not a good idea actually, because these different colors are distracting, and you can't see the pump underneath. So you know what? Making good data is hard. Yeah, it's like I can see his thing underneath, so I know it's there. But if I'm using his data underneath, well, then I'm making mine not as good, right? His works, yeah, because he goes away from the roads, and the roads are what you need to see, whereas I'm covering either side of the road with what I'm doing. So one might futz around and change this data such that you just put in the center road, you don't really care which side it's on. Maybe horizontal lines would be better, because more of my data is oriented that way. Let's try it. Horizontal lines. Also, I did not know that like Matplotlib had these lines built in. That's actually a little bit better. Yeah, I kind of like this a little bit more. So you can get some sense of what's going on here. And like, oh, there's a couple big cases here, a real big case there. But you still see there's one pump here in the center, about which the bulk of the cases are occurring. None of these other pumps. Yeah, not, centered around the workhouse, just this part of Broad Street. And there's a pump right there. So that's probably as good as it's going to get. I kind of like that. I mean, you could add a title, some other things. Fix up this map so it doesn't look like hot garbage that I have. Lots of nice things you could do. But I wouldn't worry about those things too much. Okay, I'm just glad we were able to make this work, even though we didn't have any actual geo-processing stuff. Does that make the things bigger? Not really. We were able to just convert the geo whatever shapefile stuff into a bunch of CSVs. That's the key data that we needed. That's the get my hands on the data, then I can do whatever I need to do to it. And yeah, sure, we had to do our own little transform on the data, but these things can be figured out. And by doing those, you understand better, like, what are the problems in your data? If you would just blindly plotted these, you might never have figured that out. We were careful. We set one given center, put everything around that same center point, then made our transform, so we didn't have to do a translation as well. That saved us a lot of headache. And then we're able to plot everything on one pretty nice curve here. That's pretty cool. There's just center things. So this was one of the key breakthroughs that helped people understand not just where this particular epidemic came from, but where cholera comes from. Bad water. So if you ever play like Oregon Trail and you get the display tip of bad water, your characters are probably going to get cholera. And it's going to be a bad time for them. So data can help us understand diseases. They can help give us clues about what are the right things we need to investigate. They are not a substitute for the hard science of, like, okay, there's a problem with the water. What does that mean? That can mean a lot of different things. In this case, I think it was like fecal matter was getting into the water, and that's really what the particular contamination was. But I'm not an expert in that. So these kinds of things can make a big, big difference. I think I've rambled on for long enough now. So thank you all very much for watching. I really appreciate that. Glad we got some good questions in the chat. And we'll be back again next week with more data. Probably a new problem since we were able to get this done in just about an hour. I'm sure Jon Snow took much longer. He didn't have Slimeox. You know, if you don't have Slimeox, this will take a lot longer. All right. Stay safe in the data mines out there.